where are we? That's a pretty profound question. If we didn't know where we are, we'd be like monkeys in a forest, totally unaware of our position in the cosmos. Fortunately, we humans know everything, from the shape of the Earth to its place in the universe. But how did we find out? I've asked 3 ordinary people to come on a journey of discovery. The first step is to measure our planet. How big is it? And is it really round? The volunteers don't know it, but they are going to find out the size and shape of the world right here in Nevada. They'll do it by tackling their first challenge. How flat is this lake?
How do you measure a flatness of a lake?
With a huge ruler.
Yeah, she has a point, though. You need something that you know is flat to measure the surface of the water against.
Yeah.
This lake holds the secret to the size and shape of the Earth. But can the team work it out? To help them, they need a few tools.
2 feet, 7 inches.
First is a powerful laser, which projects a straight beam of light across the surface of the lake. Next, they'll need a boat.
Bye. Whoa, we just passed through it.
Yeah.
Joy to boat.
This is Kat. Over.
I want you to go at the front of the laser.
Roger. Now we're gonna turn a little to the right.
If the lake is flat, the laser beam and the water will always be parallel to each other. Seen from a boat, the beam would always stay at the same height above the water, no matter how far you travel into the lake. But does that happen? And can the team work out why? Time to find out. The boat has a whiteboard attached to it, which will be a target.
We're looking for the laser beams so that we can mark it on the whiteboard.
Oh, it's hitting off that. And we made the first measurement, and I was pretty confident that we weren't going to find anything.
A little more to the right.
Almost there. Here we go.
They take their first reading 500 feet from the shore.
Okay, that was the height of it. Got it.
For the next measurement, they'll need to go much further out.
Okay, so now I need to go 3 miles away from the laser.
All right.
Awesome.
So 3 miles away, where is the laser beam? Remember, if the lake is flat, it would be the same height as before.
Kat, you have to go slightly to the left.
You said go slightly to the left? Yeah. A little bit more to the right.
Here we go.
I don't even think this beam is gonna hit our boat. So we're gonna have to measure it on something else. All right.
No idea. Considerably.
Here we
higher.
go.
Oh, is that your measuring tool?
Do you see it?
Yep.
Can you mark it? Let me scoot you.
We made the second measurement, and my whole world fell apart. It's like 6 feet.
Yeah.
Yeah.
It seems a lot higher.
Okay.
You got it?
Huh?
All right.
Just 3 miles away, the laser seems to have risen by 6 feet. But we know the beam is level, so that suggests that the lake is now 6 feet lower.
To see a 6-foot drop when everything looked flat to me was kind of mind-boggling. definitely kind of shattered my perspective in about 1 second. It made me rethink what was going on. Perception is still, it's a flat lake, but...
So it's not a flat lake.
It's not a flat lake.
That was crazy. I was definitely blown away by the fact that the laser was that high off the water.
My volunteers have discovered the lake is not flat. But in order to measure the whole world, they need to make a new measurement much further away. And to do that, they will need some new tools.
Okay, let's get this box open.
All right.
Yeah.
All right, what do we have here?
Tripod.
It's like a tripod.
Now, instead of a laser, a telescope will enable our volunteers to look in a straight line to the lake's opposite shore. But that's not the only instrument they'll need.
We're wondering, okay, how we're gonna get this next point if it's so high it's past our board.
Whoa!
Very cool.
Are we getting in a helicopter? This chopper appears out of nowhere. All right, that is awesome.
Just as the telescope replaces the laser, a helicopter takes the place of the boat.
I'll stay with the telescope.
Okay, great.
We'll go in a helicopter.
That's a plan.
Sounds like a plan.
Yeah.
All right, let's do it.
All right, we'll go ahead and lift off.
This is exciting.
I love that there are no doors. We're flying to Pyramid Rock. Do you copy that?
I copy that. You are flying to the pyramid.
The lake looks completely flat from up here.
If they are twice as far away as before, how much lower will the far shore of the lake appear to be?
Jim, we're going to be at the top of the Pyramid Rock.
I got him. Yeah, I have you on the telescope. Go ahead and land. As it lands, it completely disappears from my line of sight. Joey, are you still airborne?
Yeah. Can you see us landing?
The reports from the helicopter, they're still flying. But I can't see it. To wrap your head around it in that short a time was a little difficult for me. I was like, this is crazy.
We have landed in our position.
Okay, Joey, go ahead and lift off.
They plan to ascend until Jim can see them on the horizon. Then they'll tell him their altitude.
Let me know when you can see us on spot of the horizon.
I got him. I got him. Okay, what's your elevation right now?
All right, Brian, how many feet are we above the lake?
24 feet.
Woo! We made it! 24 feet.
24 feet. Awesome.
24 feet is a lot higher than our other 2 points that we got. That was awesome. It was great.
At 6 miles, the lake has fallen 4 times lower than before. So what is going on?
Okay, guys, check this out. So, if this line is our laser beam
Right.
that we shot across the lake, right? And that's the shore. This is the laser right there. And we join our data points at 6 feet and then all the way out to 24. This is our source. That's our flat line, right? And this is the surface of the lake.
The green line shows the path of the laser and the view from the telescope. And the gold line shows how the data points form the beginning of a curve.
So that means this lake isn't flat.
It's not even close.
No.
That's crazy. If we can just continue that curvature all the way around, complete a circle, and we can measure it, then that gives us the circumference of the Earth.
With these measurements on the lake, we can calculate that the Earth's circumference is around 25,000 miles, which matches Eratosthenes' calculation.
I still have a hard time wrapping my head around the fact that we measured the Earth at that lake.
I'll never look at a lake the same way. I'll never look at a big body of water the same way now that I know it's following the curvature of the Earth.